Today we're taking topic 1.7, which is the last new topic in chapter 1, solving problems involving objects. Here we have a grain bin, as you can see in the picture. It's made up of two separate parts. It looks like it's got a circular cylinder on the bottom, and then it's got a cone that makes up the top part. The question here is, if the farmer's grain truck can hold 550 cubic feet of barley, how many truckloads are required to fill a bin? Well, a composite object is what this is, and a composite object comprises two or more distinct objects. To calculate the volume of a composite object, what we have to do is identify the distinct objects and then calculate the volume of each object and then add the two volumes together. In example 1, we're going to determine the volume of this composite object. So here we have the volume of a composite object, and when you look at this, you have to examine and try to determine what kind of parts there are. Well, if you look at the bottom of this, it looks like it's a rectangular prism, and then sitting on top of it is a rectangular pyramid. So we're going to say the bottom is a rectangular prism. Top, as I mentioned, is a rectangular pyramid. And so what we're going to do is we're going to find the volume of each separate part, the bottom and the top, and we're going to add the two volumes together to get the total volume of the composite object. So the bottom is going to be length times width for the base times the height, and the top is going to be length times the width times the height divided by 3. Therefore, what we're going to have is 6.7 times 2.9 times the height of 2.9, and then we're going to get the volume as being the length times the width, which is 6.7 times 2.9 times the height of the prism, of the pyramid, the top, which is 2.1 divided by 3. So the bottom has a volume of 56.347. The top has a volume of 13.601. To get the volume of the composite object, you have to add those two volumes together. And you're going to get 69.948, or approximately 69.9 cubic meters. Here in example 2, we're going to determine the surface area of the composite object. And to calculate the surface area of a composite object, the first step is determine the faces that comprise the surface area. Then calculate the sum of the areas of those faces. Well, when we look at the faces, the first face is the bottom. The bottom is a circle, so that's pi r squared. The middle surface is the middle surface or the side face of a cylinder. And remember that since a cylinder is 2 pi r squared for the two ends plus 2 pi r h for the side of this is going to be the same, 2 pi r h. The top is a hemisphere, so that would have an area of half a sphere, or 2 pi r squared. Now we've got the area of each of the faces. We can add them up, and we can say that the surface area would be 3 pi r squared plus 2 pi r h. Because we can add 2 pi r squared for the top, 1 pi r squared for the bottom, to get 3 pi r squared. Now we simply substitute our values. We know that the r is 2, and we know that h is 4. So plugging that in, 3 pi times 2 squared plus 2 pi times 2 times 4 gives me a total surface area of 87.96, or 88 square feet. In our last example, we're solving a problem related to a composite object. It says a cabana sucra is a composite object formed by a rectangular roof with a right rectangular prism as its roof. Determine the surface area in square yards. Now this one is going to have no floor, just because in the book it doesn't have a floor when you look there. So what we're going to do is we're going to find the area of each face. First of all, I need all my dimensions. So I'm missing the side x, and so I'm going to use Pythagorean theorem to find out what that side is going to be. If I take half of 3, I'm going to get 1.5 times the height of 2, a squared plus b squared equals c squared. And I'm going to find my value of c to be the square root of 6.25, which is 2.5. Now I've got my dimensions. I can say that the front and the bottom, the front bottom and the front back, the two yellow areas, is 2 times length times width, which is 2 times 3 times 2, or 2 times 3, which is 12. So again, those two yellow areas that I shaded quickly and erased quickly, is going to be 12. In the next part, the front left and the front right side, those two sides right there, those are also going to be rectangles with a length of 5 and a width of 2. So there we go. That's going to be 2 times 2 times 5, or 20 for those two sides. Next, I'm going to need the two flat roofs. The roofs are going to be two rectangles. The bottom, the width of the rectangle is going to be 5, and the length of the rectangle is 2.5. And 2 times 5 times 2.5 gives me an area of those flat roofs of 25. Lastly, I'm going to need those two triangular pieces. So the roof ends are two triangles. Those two. And since they have a base of 3 and a height of 2, I can say that it's going to be base times height divided by 2 times 2, and that'll be 2 times 3 times 2 divided by 2, which gives me an area of 6. So those are the 4 different dimensions that are, or measurements that I'm going to need to figure out the surface area. Now all I have to do is add them all together, and the surface area is going to be 12 plus 20 plus 25 plus 6, and that's going to be 63 square yards. This takes us to the last lesson in Chapter 1. For tomorrow, your assignment is, first of all, to complete all of the check your understanding questions in this section, and then to go on and do page 59, numbers 1 to 5, and number 10.